Thank you. Oh, it works as well. Brilliant. Yes, I was going for the longest title, but David Haskier has beaten me if you look at the conference program. So if you really want to see the talk with the longest title, that's, I think, in the next, after the coffee break in the other session. Anyway, so what I'm going to talk about is, as we heard and as we all know, that metadata is difficult. And when you get aggregated collections, you get lots of, everybody uses a different classification system. Everybody uses different metadata, uses it differently, and that's okay, as long as you just want to search. If you know what you're searching for, then that's fine, because as long as you can somehow guess at what the keywords are, then it's fine. And it's also okay if you just want to get something recommended. Now, what does somebody else has looked at, and you want to look at the same, you're not feeling creative, so that works fine as well with the metadata and with the data that we have, and it works really well. It's good fun. You see some interesting typos and also combinations of things. So that's fine. But the problem is, what if you don't want, if you want neither of those, if you want to find out what is there, if you just want to browse around, that works nicely. If you're on Wikipedia, it works. You can spend or waste many an hour, but it's more difficult if you have no unified metadata. And so what could you do? Well, you could use an existing thesaurus to help you browse around. The problem is that would probably only apply to a tiny fraction of the collection. So you can browse that, but there's all the rest, which might be interesting, but which you can't see. You could use multiple thesauri, but then you'd have to use each one separately. That's also not ideal. Now, the next one is the ideal solution. Now, ideally, you'd get people in, you'd have enough money to pay them all, you'd have enough money to pay the people who check that the people who did the classification, did it properly, and then you'd end up with this beautiful manual annotation that you, of course, have to update every time you add an item, but still, it would be beautiful, but expensive. So that's also probably not a viable way forward, and what we in Sheffield have been playing around with is automating this process. Basically, using an automated process to give us a rough classification that is sufficient. It's not necessarily good. We've done some experiments. It's okay. And it probably won't get better than okay anyway. So what we've been playing around with from the purely technical point of view is statistical topic models, and specifically something called Latent Dirichlet allocation. We've also I'll show something with a Unifying Thesaurus, but that's just side work. So basically what these automatic models do is you have documents, and so these are the Europeana items, and the metadata, and there's words in those documents. And these documents have been mystically created based on a set of topics. Now, you don't know what the topics are, because there's so many. So you use a statistical approach to essentially guess what the topics were initially that generated these documents with these words. And that works quite well. And what you can then do with that is, if you get all these topics for your millions of items, you just have the topics, and you can then display the images, for example, as a grid. And actually, that gives you a very interesting overview of what is in this bit of the collection. This is a very small subset of Europeana that we've been playing around with, but you can see roughly what kind of stuff is there. And click on it and then have a closer look and see what are all the items in the topic. Alternatively, you could sort of create a small set of topics, say 9 or so. Those are the main topics. And then for those 9 topics, You split the documents into those 9 topics, and for each of the 9 topics, you create another 9 topics. And you create another, and you split it down and you get a long, big tree of topics. So, and then you could sort of use that just to click through and browse through the data. So here, for example, you'd see something that's the overview of everything that's there in the collection. Then we've clicked on the bowl in the middle, and then the bowl topic has other bowls and things that don't fit. And it's important, this is purely automatic. It's statistical guesswork. It works mostly, but you get items. You will always get stuff that doesn't fit. However, we've done some experiments, and we've shown that we can see that humans do that as well. So as long as if humans are happy with a bit of variation, let's call it, then the machine should be fine. Another approach is to use, if you've got your one big favorite thesaurus that you definitely want to use, then another approach is to mix the statistical topic models, which give you the most important keywords. And that's the nice thing about them. They give you those keywords that are most important, or statistically most important, and nobody knows whether they actually are, but they tend to be. And you can then use those to map items into your thesaurus. And that allows you to map items that come from different collections that have been annotated differently into your own thesaurus. And you can see everything through the eyes of your own classification. Of course, that some of the things will be misclassified, but that's the way it goes. Right, to conclude, it works sufficiently well. It's very flexible. It can deal with large collections, so it actually requires quite a lot of processing power, but you can parallelize it, and then it's doable for millions of items. It's language neutral, except for the thesaurus bit at the end, but the other topic models are entirely language neutral, and you'll end up with a topic essentially, or multiple topics for each language, because they are statistically distinct. 3 minutes. Oh, I'm a bit too fast, sorry. The important thing is it's not as good as manual classification. It never will be. But it's something that you can do when you don't have the option of manually classifying. And we recently ran an experiment using about 30,000 items, which we manually classified and which had manual classification, consistent classification, and which we also classified automatically. And the manual annotation was judged to be good. This is a qualitative judgment, which I won't go into any deeper, was judged to be good for about 85% of all topics, whereas the automatic one, the best automatic algorithm that we've got so far, is good for about 65% of the data. But it is, now the interesting thing is the automatic stuff is almost good for another 20%. So if you include the almost good in the items that in the classification quality that you have, then the algorithms can almost reach human level. But it's usable. The data is sufficiently usable. It's the wrong button. Thank you. Yes, we've been hacking away on some of the interfaces in the hackathon. So actually on something similar but completely different. But still, at the time, I thought I was going to be doing something different. And if you're interested, there's a poster up front and leaflets hanging below it about our project paths, which will make use of all this magic technology. And I've got more leaflets as well. I get paid per leaflet. So